During the movement of the planet around the Sun, the constant magnitude of the angular momentum vector leads to the constant areal velocity of the planet, and the fixed direction of the angular momentum vector indicates that the plane of the orbital motion of the planet around the Sun must remain fixed.
Now, if no external forces acts on the system, then both the linear momentum and the angular momentum of the system remain constant. ਤੁਸੀਂ ਵੇਖਿਆ ਕਿ ਸਨ ਦੇ ਦੁਆਲੇ ਘੁੰਮ ਰਹੇ ਪਲੈਨਟਸ ਦੇ ਮੈਗਨੀਟਿਊਡ ਅਤੇ ਐਂਗੂਲਰ ਮੋਮੈਂਟਮ ਕਾਂਸਟੈਂਟ ਰਹਿੰਦੇ ਹਨ। ਆਓ ਇਸ ਨੂੰ ਮੈਥਮੈਟਿਕਲੀ ਐਨਾਲਾਈਜ਼ ਕਰਦੇ ਹਾਂ। Consider a planet moving around the Sun in elliptical orbit. Let vector r be the position vector of the planet with respect to the Sun and vector f be gravitational force on the planet due to the Sun. Then the torque acting on the planet due to the force exerted by the Sun is given by vector tau is equal to vector r cross vector f. The force on the planet always acts along the line joining the centers of the planet and the Sun and is directed towards the Sun. As a result, the vectors vector r and vector f are parallel to each other, and consequently vector r cross vector f is equal to 0, implying that vector tau is equal to 0. Since the relation between the torque acting on the planet and its angular momentum while it moves around the Sun under the gravitational field is given by vector tau equal to d vector L by dt. Now vector tau is equal to 0 or d vector L by dt is equal to 0, which in turn means that vector L is a constant vector. Thus, the planet moves under the gravitational force of Sun in its orbit with the constant angular momentum. Since the angular momentum of a planet is also given by vector L is equal to 2m into delta vector A by delta t, where m is mass of the planet and delta vector A by delta t is the areal velocity of the planet. Since angular momentum of a planet is a constant, that is, vector L is a constant vector, therefore 2m into delta vector A by delta t equal to vector L is also a constant vector.